We live in a time of global transformation. The Energy Futures podcast explores how we can accelerate the expansion of clean energy technologies and reduce our reliance on fossil fuels. From heating and cooling our homes to moving around our planet and beyond, we bring together researchers, scientists, business leaders, and communicators to exchange knowledge and try to answer one important question. How can we create a sustainable energy future for all? This podcast is produced by Energy Futures Lab of Imperial College London.
Today we're joined by Rayan Kassis, co-founder and CEO of Aed Energy. With decades of experience in clean tech development and over 9 gigawatts of operational projects spanning 24 countries, Rayan shares insights into the UK's key energy challenges, the critical role of long-duration storage in grid stability, and the future of renewable energy integration. He also discusses Aed Energy's innovative thermal battery technology, which uniquely delivers both electricity and heat, and its potential to transform global energy systems. Cool, Rayan. So for the last month, I've been traveling around the whole country, speaking to the many influential people within the energy industry. And I asked this key question, which I'm going to ask you today, is what are the key challenges the UK have in the energy transition and moving towards zero carbon? And one of 3 things keeps coming up. It's either grid infrastructure, distribution, or batteries. It's normally one of those 3 things.
Yeah.
So I'm excited today to talk about you and your company and why batteries are so important in this transition globally to net zero. So talk to me a little bit about you and the company and what it is that you do.
So thank you for having me. I am the co-founder and CEO of Aed Energy. We're developing long-duration energy storage technology. So intended to be very low cost and dispatch up to 100 hours. And I'll just give you a little bit of background. I come from the power generation side of the business. So for me, of course, power generation is important, but the grid is number one. If you don't have the proper background, you can make all the plans that you want, and you simply won't reach there. And that's been quite an issue in the UK with all the backlog of grid connection permits to access both the medium voltage and the high voltage transmission lines. So transmission is extremely important. Energy storage is complementary to that. You need to balance larger and larger amounts of renewables to be able to provide managing demand and supply, balance the grid. But the backbone remains the grid. So I think that is the number one challenge. It's not just a UK challenge, it's a global problem. Both national grids, how do you interconnect, what is the level of interconnection, and even interconnection becomes a political issue. I've seen projects where the idea is to transfer renewable energy from very low cost countries to the UK, or from very low cost countries like Australia that has abundant solar to Singapore, for example. There are these mega projects that are in planning, and they always come up with the same complaint, is that we're depending on other countries for our energy needs. Well, you're depending on your energy, other countries for your energy needs in a fossil fuel scenario anyways. So, I mean, these are, I think, minor issues. I think if you look at the fundamentals, the grid is the backbone, and then getting a suitable power generation mix that's stable enough and that you plan appropriately for is what national policy should be. And I don't think the UK has been, I think it's been at the leader of the pack, I would say. Maybe it's lagged in the past 10 years, but it's coming up strong now. Renewables is like 40% of the national average. If you combine it with nuclear, renewables, it makes up the majority of the fossil fuel mix. And that's in a span of 10 years. It's completely switched the fossil fuel story. Fossil fuels was the majority 10 years ago. It isn't now. So I think despite the challenges, I think we're getting there. But definitely the grid needs to be strengthened, especially if you're going to start putting up more offshore wind plants. Those are mega projects. They're not small projects. They're going to deliver at peak wind times massive amounts of energy, and you need a strong grid for that. So I'm very optimistic. In terms of where the UK is going. But the key thing is to reduce volatility and keep prices down at the end of the day.
You're positive then.
I think in the right that look at the numbers: 40% renewables, where it was the majority fossil fuels, and renewables today are cheaper than fossil fuels. So from a cost point of view, you're going in the right direction. Of course, you're going to reach some limits in terms of maximizing renewables unless you implement battery storage, which is where battery storage becomes increasingly important. This is a key point to note as well, is that I've been in the sector for 20 years. When I started, wind and solar was globally nothing. It was less than 2%. It was considered way too costly and will never get down to the proper cost. And more importantly, it was considered unstable. So me coming from that background, base load generation, when I moved to wind energy in 2009, 2010, my colleagues they couldn't believe what I was doing. I said, "What are you doing? Going to wind? This is where we're doing real impact." They were doing real impact, and they still are. But the fact is that wind and energy now are the cheapest source of electricity. Maybe solar is a challenge here in the UK because of where we are, but it still delivers very low cost of electricity. And the issue to maintain a stable price becomes batteries at the end of the day. And not to pitch our business, but and our technology, but lowering the cost of that becomes very important to deliver round trip low cost of energy.
Okay. Well, we've touched on about 2 or 3 things there that we'll move on to in a bit. So we talked about batteries, which I'm sure we're going to be talking about a lot in a bit. But we also talked about the stability of grids and how grid infrastructure needs to be not paramount, but it's a super key important when building the infrastructure for energy. But you also touched on a couple of bits of your background, and I'm going to jump on that now because I think it's really interesting. Talk me through sort of even from education, how you educated, where you studied, and then so I suppose let's go through the last sort of couple of decades and how you've arrived where you are today.
Well, I would say I'm a second generation power generation person. My father was in the power sector in combined cycle power plant. He actually helped me get my first job as an intern, analyzing energy trends specifically for gas turbine power plant technology. I started my career in application engineering. My first assignment was doing heat balances for combined cycle power plants. In fact, it's probably the assignment that still stays with me today. This is from my GE days. Just because it wasn't just heat balances. How do you transfer heat balances into a technical, economic, financial model for a large-scale power plant? In that case, either simple cycle or combined cycle power plants. So I carry those lessons to this day, regardless of the fact that that was a very brief stint, and then I moved to the commercial side, and I was in sales. I worked at a repair shop for some time, looking at how we repair gas turbine blades and vanes, but that lesson of translating the technicals to a technical commercial model, I still use to this day. In fact, one of the Excel sheets that I never delete comes from these legends of technical economic analysis that I was working under at the time. So that is the base load background that I came from, and I think that's also a legacy that I still carry to this day, because I understand what on-demand power means. It means less headaches for the operators, and ultimately it means that you can more or less accurately model what the cost of a power plant is going to deliver over, let's say, 20 years. Of course, unless you get crazy events where renewables becomes a huge part of the system, and you start to retire gas plants and their economic model falls through, which is, by the way, the reality of what's happening. I think that base load mentality I still also carry to this day. What we're doing is trying to mimic base load capacity by combining an intermittent renewable energy source with a stabilizing factor, which is energy storage. So I personally see the combination as a single generating unit. At the project level, people are going to say, well, this is solar, this is wind, but what we look at is how to mimic and how to replicate the effect that what the grid needs, which is stable power that you can dispatch on and off.
So you've, over your career, you've worked at GE, General Electric, Vestas.
So yeah,
and eSolar.
Mm-hmm.
What were the key lessons that you've learned through that period of working for those organizations? What can you take away?
Well, I mentioned GE, and I think GE was, coming off, as my first job, basically. It gave me the grounding of a large organization, how multinational organizations work, the importance of services. So having a very robust services organization is critical. For a company, but also for the functionality that you're providing. So it gave me that global cross-boundary outlook. We were working on project. It didn't matter the geography. Somewhere in Indonesia, somewhere in Arizona. A lot were in the Middle East. So. And then you see how the service centers and how sales organizations work. What's the crossover between the technology functions and the commercial side? So that was very valuable. And when I joined, GE was, a nearly 100 years company, that's gone through, huge growth, and that opened my eyes to that side. Moving to Vestas did a lot of things for me, which is, first of all, it got me out of my comfort zone. All of a sudden, after talking baseload power plants, I had to actually explain to regulators, to operators, to customers, what is this that you're wind energy? Like, how does that fit? And this is exactly what I said. Wind and solar were 2% of the global generation mix. So
you said when we're at the beginning of this conversation, before we started recording, that when you told your friends that you're working in wind, they thought you'd gone mad.
They thought I'd gone mad. They said, "Why would you do that? We're doing real impact here, and we're building stuff, and you're gonna do wind? There's things that move around." But I was just attracted with renewable energy. It was, eventually, let's say I proved them wrong. Wind energy was on a trajectory. But it's kind of instrumental in technology and just how organizations work, because I joined wind, and this is where I saw an organization that was growing, so I could see the gaps, and I can, coming from G, I can see what they were doing right and what they were doing, kind of what they need to focus on. But I think it was a quite well-run organization. But at the time, we were talking about solar PV and saying, no chance, way too expensive. Customers, that's why, it's inevitable that people are in their silos. It's just a human nature. But, solar completely surpassed wind energy now. Wind energy is still very relevant and low cost. But this is where, for me, it gave me the perspective that just pay attention to what's going on.
And at what point during your career did you start looking at batteries and thinking, this is the area that I really want to sort of get in now? And I suppose just to follow on that, at what point were you when you decided this is actually, I think there's a business opportunity here?
Well, batteries are a no-brainer. And I've also been a developer of projects, wind and solar projects. So I've seen the transition. Initially, it was governments and entities were issuing tenders for, let's say, solar energy or wind energy. And batteries weren't really an issue then because they weren't really part of the conversation. Wind and solar were so minuscule that it was just dropping a bit of energy into the bucket. So it wasn't a real concern. And then starting, I would say, around 2014, 2015, Tesla started to market their battery packs. I think they were quite instrumental in kind of pushing that envelope in terms of what utility scale lithium-ion can do. So that is where we started to see tenders that had shifted. Now they were like, yes, we want a wind plant, but you need to give us battery functionality. So you can see that transition in the strategy of the operators who have to deal with all this strain on the grid, that wait a minute, yes, we want wind energy, but we also want a stable system. So it wasn't a real jump. It was a no-brainer to do that. But I guess what got me into what we're doing is I'm attracted by low-cost things. I've been around the world. I like engineering designs that make sense, but they have to be translatable. Otherwise, they might be nice in, let's be perfectly frank, they might be nice in countries with high incomes, with banking facilities, because they're high capex, high complicated, but they're not going to make a dent in impact. So for me, having that's why I like solar energy. You democratize energy. Someone in a village in the middle of nowhere could put solar panels and have some electricity. So that was an attraction to me. And really what got us to start Aed Energy was my experience with eSolar, which was basically tackling the holy grail of renewables, which is how do you create dispatchable energy. And what eSolar was doing, they were doing concentrated solar systems for tower-based projects, meaning you have an array of mirrors that concentrate the intensity of the sunlight, direct sunlight, onto a central receiver, super hot, burning hot. That central receiver is basically a heat exchange system, and it generates vast amounts of steam. But what you can do with it, and this is where the holy grail of renewables is you can heat in the same receiver, you can heat salt, molten salt, dirt cheap, very high energy dense salt, and store that molten salt in vats so that when there's no sun, you convert that molten salt heat into steam, so driving the same system. So that was for me, that was attractive coming from wind. It's like here's a system that can deliver what you're doing, but can deliver it on demand. Unfortunately, CSP is not. It's very geographic based. You can't just put it anywhere. It needs very pure, direct sunlight of high intensity. So places like Chile and some areas of Morocco. But otherwise, the performance doesn't add up for the cost that it requires. So it's a very high capex system.
Well, you mentioned Chile and Morocco. Is that the weather, or is that to do with the salt as well? Or is it
No, that's just the geographic conditions.
Right.
In some parts of Morocco and Chile is actually the highest. You have extremely high direct sunlight that is shining for a large period of time during the year, and there's no particles in the air. It's clear as can be. Obviously, the clearer the better. So you have a few areas in the United States,
Middle East.
Middle East. There are a few projects in the Middle East actually. Masdar. I mean, not Masdar. Is it Masdar? They have one of the largest concentrated solar plants. I think the plant is 1 gigawatt. Not tower based. They have different technology, but Morocco has led the pack as well at quite very low cost of electricity. I think it was like 12 cents per kilowatt hour. Again, very geographically based, very high capex solutions, but you can deliver very complex systems. You're talking about millions of square meters that you need to have mirrors everywhere. You need to account for how do you clean the mirrors because it has to be, very clear. And then the question is how large are these mirrors? eSolar was doing very small mirrors to tackle that same problem of infrastructure. Others said no, you have to go big mirrors, easier to clean and all that stuff. So everyone had a different approach. It was there that I got the kind of that understanding that molten salt storage is extremely cheap. Talking about salts, that you can source pretty much anywhere. But what do you do with it? Can you, traditionally, most of thermal storage now is to deliver steam or to run a steam cycle. That's kind of the bulk, the 95% of what is called thermal storage now is you convert it to electricity. And then you either augment an existing power plant cycle, so hereby kind of reducing their dependency on fossil fuels by putting in extra steam, or you actually do a steam cycle yourself. So a bit complicated systems because you can't just do small micro steam turbine. You can, but it's going to be, the numbers don't really add up.
Was there a light bulb? Pardon the pun, a light bulb moment, or was this a gradual process of many years of extracting tech and innovation and seeing things, and eventually arriving at this place where you thought, there's an opportunity here?
Well, from a company, it was a single conversation with one of my co-founder, Oli, who introduced me to the possibility of using the photovoltaic effect in a molten salt medium, and that kind of opened my eyes. But I didn't, and that goes back to my first lessons with GE. I needed to get the numbers right, So we did a whole exercise that took months to kind of look at the numbers, look at the projections. Where can we be? Can it really be a low-cost system? Or are there hidden things that we're not aware of? And essentially, that is what made us start the company, is that we were convinced that we can do it. And we brought another co-founder, who was actually the head of application engineering at eSolar, who's a thermal storage expert and a power plant software expert. And we all hit it off in terms of both personally, but also from a technology point of view. You can deliver, if we deliver what we think we can deliver, you're talking about a system whose capex is multiple times cheaper than the cheapest lithium-ion battery out there. So in terms of accessibility to a lot of areas of the world, capex is extremely important.
So explain to me capex.
Capital. So the cost of the equipment.
Right.
The cost of equipment is much lower. Sorry, I'm using industry.
That's all right. No, that's fine.
I'm using Excel sheet terminology.
I kind of knew what you meant, but I thought we'd better explain it for the audience. And actually, this leads me on to my next point, because we're definitely going to. I'd like to talk more about the organisation and your founders in a bit, and we'd also talk about Undaunted, the program that you've been on. But before we do that, you said something really interesting about dispatching energy from batteries and the grid. Now, our audience will vary from people from sort of lower baseline knowledge to probably more technical knowledge. But just for the audience that are listening to this in terms of batteries, grids, and dispatching energy, let's just talk about that overview. Explain how the grid works. You can do it in the UK or globally, whatever makes sense. Where batteries sit in that and how energy is dispatched across a network or grid.
Well, there's many ways, and this is depending on the grid itself. What the strength of the grid, what are the generation sources on this grid. But energy storage works with different functions. So if you're talking about at the source, so let's say you have a very large scale wind project, and it is 100, 200 megawatts, and at peak capacity. So the peak capacity of wind might not match with the demand on the grid. And in many cases, the operators will tell the wind suppliers that, sorry, we don't take your energy. So it's basically completely lost energy. So that's one function. So kind of market-driven, but also demand-driven energy storage needs, where you have energy storage near the source of generation that's absorbing the extra energy and dispatching it when demand catches up with, so you're not losing. So that's a lot more applicable for wind, but also you see that in solar plants where you can't control when the sun is at its peak, and demand and supply shifts from hour to hour.
Day and night.
So that's one function of energy storage. Other function of energy storage is grid stability, where you have too many renewable energy plants. Operators in many countries place batteries to kind of manage the distribution of energy along the grid, so lower frequency fluctuations. And then you have on the demand side. This is partly market-driven, so arbitraging when costs are very high versus when costs are very low. So many industries and companies look to maximize the economic benefit of that. So when prices are low, they'd rather store that energy, and when prices kick back up, then they dispatch their energy storage. Ideally, that the round trip cost of that dispatching is less than the peak of storage. So that's kind of the general applications. And then there are microgrid applications. So areas where the grid is weak or you're remote, you're always going to need some sort of microgrid. And this is where energy storage combined with another source of generation can provide that same on-demand power. Meaning you size a solar plant, probably you size it, you oversize it, and then you store that energy so that in the evening or when there's no sun, you can deliver electricity for whatever application, whether it's a community or a university or an industrial plant that needs that.
Okay, brilliant. That's much clearer. I know there's only so much you can say because you're still obviously a startup and the technology is still in development. But if you could explain to me what batteries are we currently using across the board? What are the challenges with those batteries, and how are you providing a new solution?
Well, first of all, so solar and wind today are they're going to reach 17% of global electricity production by the end of this year. So this has driven a huge attention and increase in energy storage capacity worldwide. So rapidly replacing fossil fuels for peaking applications and many of the other applications that I mentioned. And this number is set to, so wind and solar is 17%, it's set to triple by 2050, according to the pledges that have been made to decarbonize. The most viable plan is to increase this cheap solar and wind energy. There's no other, there's a lot of ideas, but this is the only concrete plan. And to achieve that, you need to, all the targets are in the terawatts. So the latest forecast was, the previous forecast was 450 gigawatts. That was a few years ago. And because of how the market reacted, and this tells you how the market's a reactive market, and the sector is a reactive market. The targets today, the G7 announced 1.7 terawatts, so six-fold increase by 2030. It's just around the corner. And by most estimates, by 2040, it should reach up to 2.5 terawatts. To put it into perspective, that's 10 times more than all the energy storage available in the market today. And the market today is dominated by one technology, lithium-ion batteries, which of course are vastly better than burning fossil fuels, but they have limitations. They're a short duration solution that has supply chain issues. I mean, you have to source it. You have to mine this material. I think Elon Musk had said that lithium was actually, lithium-ion was a misnomer, that the lithium is like salt on a salad. The rest is cobalt and other material that all that you have to source in different areas of the globe, and they have inherent safety issues. Those are solvable, but these are the issues with lithium-ion, and this is where longer duration storage is becoming increasingly important. If you're anticipating a market that's 3 times more solar and wind. If you're going to base it on 17%, yes, let's stick with lithium-ion. But as you increase, you do need to absorb that vast amount of energy so that you manage demand and supply. And this is where a lot of attention is starting to kind of be placed on longer duration storage. I think the most recent target from the Department of Energy in the United States was they mapped out several long duration energy storage pathways as a order of national priority, with a target that one or more of them have to reach a cost of storage of $0.5 per kilowatt hour by 2030. And they did a good mapping of all the different options. And to put it into perspective, the cost of storage today from lithium-ion is, and any other technology, is probably triple that. And that's only for short duration. It's kind of like adding Legos. With short duration, if you want longer duration, you add capacity, but that doubles your price, basically. So you don't really achieve long duration capability. And this is what is driving what we're doing, is that we're dealing with a thermal storage medium that you can get anywhere. It's rock salt. I mean, not as simple. You don't put just plain rock salt into our system, but it's one of the highest energy. If you heat it, it's very high energy dense, and we know how to contain it. And it's a solid state engine that just sits there, absorbs power, heats up, then emits a bright light, and we convert that to electricity using our system.
So we're currently today at Scale Space in White City, and this is where you're running the business from. Where does the clever, fun stuff happen? Where does the technical, the building, the testing, the experimenting, where's that being done at the moment?
That's a good point. We're looking for space.
Okay.
We're building a prototype now. All the fun stuff is either in the lab upstairs or on the drawing board. We have a full team of engineers that both internally but our wider network of companies that we work with that are designing key aspects of the tech. And when we build it, this is actually a subject now, it might be it's a small system as a prototype, but it might be too big to put in the labs here. So we're kind of looking at different options.
And
but it might be able to fit here.
Okay. And in terms of an MVP, when do you think, which is a minimal viable product, what's your sort of timeline on that?
Yeah, it's a funny one. In terms of an MVP, you can define it the way you want it. But for us, having MVP is 2 years down the line. For me, at least, having an MVP is a system that is operating, that we're happy with, and most importantly, has all the certifications, the industry certifications that we need to deploy in the market. So for me, that's an MVP. But if on an optimistic day, I'll tell you we have an MVP now. All the subcomponents are well known, and we just have to build it. So it's a good question, but if you want a prudent answer, our MVP is when we've had a unit running for some time, and we get the final certifications, which we are working with all the certifying bodies, just from an early stage to make sure we cross the T's and make sure that we're building, something that is well understood and can be verifiable through operating data.
Well, when we do part two, you'll walk me around your new lab
great.
and you show me some products.
Yeah.
You mentioned two other founders. Let's talk about the three of you. What's the dynamic? What skill sets have you got? How do you work together? Who are they?
Well, Dr. Oliver Weber is my co-founder. We met at a venture builder program, Carbon-13. We're pretty much there are a few other power people, but that combination of my thermal storage background and his expertise in multi-junction PV kind of started to get us, putting together the numbers. It was, we kind of formed it with basically one condition, is if we, all three of us, give a thumbs up, then we'll just form the company. And that's pretty much what happened. Mike, he was the head of systems engineering and application engineering at eSolar. He saw it from nothing, from scratch, to building several $100 million projects, one in India, one in Australia. So he's done the whole R&D process. And one of the first things we spoke about when he agreed to join us was that me personally, I wanted to set a commercial R&D strategy that avoids rabbit holes. It's very easy when you get funding to start doing pet projects, and I didn't feel we had enough time. And I think one analogy that we've talked about is, let's design this as if this is gonna you're putting it on a spaceship, and this is the only system that's gonna get you going. So that's kind of what we're doing. We have an experienced team that isn't prone to like jump into conclusions. But I think we're doing things in just with a good focus, without doing too many distractions. And essentially, once we design and build the first one, we're designing it to be a dumb system. We want it to be as simple as dumb as possible. But to get to simple and dumb as possible, we have to really focus on every single thing that can go wrong in the system. Mm. So that's basically what we're doing.
Yeah, it's an interesting. You have interesting phases of the rollout of this product. Obviously, this is the most crucial time: getting it right, getting it safe, getting it into a good working capacity. But then the phase 2, the rollout, is going to be a whole other game in that. I'd like to, as we start to bring this conversation to a close, there's a couple of things I want to draw on. I think we should talk about Undaunted. Mm-hmm. That's how we were introduced through the Grantham Institute. Tell me a little bit about Undaunted. How did you hear about it, and what's been your experience being on the program?
It's been so we heard about Undaunted through the Carbon-13 cohorts. Some of them had joined, and when we looked at the program, we felt it was a very good fit. They were taking companies that had just recently started, that have a clear cleantech impact, and giving them a lot of the tools that you need to look out for when you're starting a business. And it can go from things like mental health, which I think is extremely important. People should not burn out, and I've spoken about this in the past. Pace yourself, but also, fundamentals on how teams work, what are the key things to put a company on the right track, accounting practices. So really giving you kind of the feel of how to operate as a maturing company. Mm. And, companies change, from when you have 2 founders or 3 founders to building a team, and the dynamic changes. You need to be aware of that and embrace it, and have open communications, and ultimately foster innovation. If someone feels that they cannot speak, then you don't have innovation. So this is what we try to build in the company. Mm.
I like the fact that you touched on the emotional factors that come with with a bootstrap startup, like. And a lot of people will tell you it's not a walk in the park. It comes with its own challenges and its stresses, and you've got to stay fit, you've got to stay healthy, and you've got to have a good solid game plan, not just a business plan, but a game plan in terms of your physical, mental, social, and cultural needs that you need to get through to the different stages. So that's a really important thing, and I think that's a real plus of the program. Mm-hmm. So my last question to you now is what advice can you give to any clean tech, climate tech startups that want to work in the energy sector? Maybe have got a good idea, got the beginning of a product. What advice could you give them?
Well, the energy sector is a quite complicated sector, and it is, previously it wasn't very innovation friendly, I would say. Well, innovation was contained by large multinationals. This has changed dramatically with solar and wind, and I credit both technologies to kind of giving ideas and giving entrepreneurs the possibility. Look at the entire life cycle, learn technical financial modeling, really understand. But that's just the headlines. I think the key thing is to build experience, with either generation companies or energy storage tech, and listen, ask questions, get a full picture, and look at the trends, really. But ultimately, the real advice I would give is, unless it's a pet project that some obscure entity is going to be interested in, look at things that are going to improve lives by lowering cost of energy, by stabilizing the grid, by providing real services. Both in terms of getting a company started, you do need that focus, but also that we are an infrastructure sector, and I don't want to sound, giving inspirational messages or anything, but part of that comes with the responsibility that you have to design things to be worth your time as well, that have utility to users. So define what that utility is, and I personally happen to be attracted to low-cost systems because I just see that you need things out in the market to make a dent.
Yeah, just to kind of echo that, having one foot in industry, having good connections with industry, people that are working within energy that you can run your ideas past, can kind of get a real insight to what's going on, where markets are moving. But I also like that fact that you touched upon is always having that end user in mind, in terms of the consumption side of things, in terms of cost and convenience and how people are using energy at home now and in the future. That's amazing. Thank you, Rayan. That's incredible. Rayan, if people want to find out more about you and Aed, is it Aed? Did I say Aed?
Aed Energy.
Aed Energy. Where should they go? Where can they find out more about you?
They can follow us on LinkedIn. They can look at our website. They can reach out anytime. We're always happy to have conversations with like-minded individuals. We're trying not to say too much on our website, but eventually we will have more content.
That's it. And I'm looking forward to part 2. We'll come and revisit.
We'll invite you to the when we install the prototype. At least you can see it running.
We'll be there. We'll be there. Energy Futures Lab. Brilliant. I just want to say thank you for your time. This has been really insightful. I've learned loads. We'll put all the details in the show notes. And thank you for your time. Really appreciate it.
Thank you.
Thank you for tuning in to the Energy Futures podcast. Here at Energy Futures Lab, we are dedicated to addressing global energy challenges through pioneering research, innovation, and advocacy. To learn more about us and the exciting projects we are working on, visit our website and follow us on social media. If you enjoyed this episode, please like and share and subscribe to stay up to date with our latest content.